When considering vertical support options for conductors on a dam facade, several alternatives exist beyond the initially considered rubber clamps and wire mesh baskets. These options can potentially offer cost savings and improve suitability for varying conductor sizes. Bolted supports present one such alternative. Anchor bolts can be used to attach conduits to the dam face, utilizing standoff insulators. This method facilitates expansion and contraction of the conduit system and can accommodate conductors of different sizes within separate conduits. Bracket supports are another viable choice. Metal or composite brackets can be securely bolted to the dam face, creating stable attachment points for conduits and conductors. Structural attachments, such as Unistrut, offer a versatile metal framing system adaptable for custom vertical supports. Unistrut provides design flexibility and accommodates various conduit sizes. Cantilevered platforms can be permanently installed on the dam face, providing a sturdy base for mounting conduits and conductors. This option allows for easy access during installation and subsequent maintenance activities. Regardless of the chosen method, it's crucial to address thermal expansion. These alternative methods may also necessitate the use of expansion couplings or other strategies to accommodate thermal expansion. Consulting with an experienced electrical contractor or a structural engineer is highly recommended. Their expertise will help determine the most appropriate and cost-effective solution tailored to the specific conditions of the dam and the electrical system. A cost comparison is essential when evaluating these alternatives. The costs associated with these support options can vary significantly depending on the chosen method, the materials required, the labor involved, and the overall complexity of the installation. To ensure informed decision-making and competitive pricing, it's generally advisable to obtain multiple quotes from qualified contractors. Firstly, carefully assess the dam structure. This involves determining the material composition of the dam, its age, and any existing infrastructure. Understanding the dam's structural integrity is crucial to ensure that the selected support method will not compromise its stability. Secondly, consider the environmental conditions. The location of the dam exposes it to various environmental factors such as temperature fluctuations, humidity, and potential exposure to chemicals or corrosive substances. Selecting materials and support systems that are resistant to these conditions is essential for long-term reliability. Thirdly, evaluate the conductor specifications. The size, weight, and type of conductors that need to be supported will influence the choice of support method. Consider the spacing between conductors, the need for future expansion, and any specific requirements related to voltage drop or current carrying capacity. Fourthly, analyze the installation constraints. The accessibility of the dam face, the availability of equipment, and the time constraints for installation can impact the feasibility of different support methods. Consider the need for specialized equipment such as cranes or man baskets and factor in the potential costs associated with their use. Fifthly, review relevant codes and standards. Ensure that the selected support method complies with all applicable electrical codes, safety standards, and environmental regulations. Consult with local authorities and obtain the necessary permits before commencing any installation work. Sixthly, conduct a thorough cost analysis. Obtain quotes from multiple contractors for each of the alternative support methods. Consider not only the initial installation costs but also the long-term maintenance costs, the potential for future repairs, and the life cycle cost of the system. Seventhly, assess the aesthetic impact. While functionality and costs are important considerations, the aesthetic impact of the support system should also be taken into account. Choose a support method that blends in with the dam's surroundings and minimizes visual intrusion. Eighthly, prioritize safety. Safety should be the paramount concern throughout the design and installation process. Implement appropriate safety measures to protect workers, the public, and the environment. Provide adequate training to all personnel involved in the project. Ninthly, document all decisions. Keep a detailed record of all decisions made during the selection and installation process, including the rationale behind those decisions. This documentation will be valuable for future maintenance, repairs, or upgrades to the electrical system. Tenthly, seek expert advice. Consulting with experienced electrical contractors, structural engineers, and dam safety experts is highly recommended. Their expertise can help ensure that the selected support method is appropriate, safe, and cost-effective. When evaluating bolted support options, it's critical to select anchor bolts that are compatible with the dam's material. The anchor bolt should be made of corrosion-resistant materials to withstand the harsh environmental conditions. The spacing between anchor bolts should be carefully calculated to ensure adequate support for the conduits and conductors. Standoff insulators should be used to maintain proper clearance between the conduits and the dam face, preventing electrical shorts and minimizing the risk of corrosion. Bracket supports offer a versatile solution for attaching conduits to the dam face. The bracket should be made of sturdy materials such as steel or aluminum to provide adequate support. The size and shape of the bracket should be designed to accommodate the specific conduits and conductors being used. The bracket should be securely bolted to the dam face to prevent movement or displacement. Unistrut systems provide a flexible and adaptable solution for creating custom vertical supports. Unistrut channels can be easily cut and assembled to create a variety of support structures. Unistrut fittings can be used to attach conduits and conductors to the channels. The modular design of Unistrut systems allows for easy modifications and future expansion. Cantilevered platforms offer a robust and accessible solution for mounting conduits and conductors on the dam face. The platforms should be designed to withstand the weight of the conduits, conductors, and any maintenance personnel. The platforms should be securely anchored to the dam face to prevent movement or collapse. Access to the platforms should be provided via stairs or ladders to facilitate maintenance and repairs. Expansion couplings are essential for accommodating thermal expansion in conduit systems. The expansion couplings should be installed at regular intervals to prevent stress and damage to the conduits. The amount of expansion that needs to be accommodated will depend on the length of the conduit run, the temperature range, and the coefficient of thermal expansion of the conduit material. Thermal expansion refers to the tendency of matter to change in volume in response to changes in temperature. When a substance is heated, its particles move more and thus maintain a greater average separation. Because thermometers are affected by this phenomenon, it is used to measure temperature. Most solids expand upon heating and contract when cold. The thermal expansion is a physical property that describes how much a material's size changes with temperature. It is quantified by the coefficient of thermal expansion, which represents the fractional change in size per degree Celsius or Fahrenheit change in temperature. Different materials have different coefficients of thermal expansion. For instance, steel expands and contracts at a different rate than concrete. In the context of a dam, which is a large concrete structure, and metal conduits used for electrical wiring, understanding these differences is crucial. As the temperature changes throughout the day and across seasons, the concrete dam and the metal conduits will expand and contract at different rates. If the conduits are rigidly fixed to the dam without any provision for this differential expansion, it can lead to significant stress in the conduits, their supports, and even the dam structure itself. This stress can cause the conduits to bend, crack, or even break, potentially damaging the electrical wiring within. In extreme cases, it could even exert undue pressure on the dam structure, though this is less likely with properly designed and installed systems. To mitigate these risks, expansion joints or expansion couplings are incorporated into the conduit runs. These devices allow the conduits to expand and contract freely without putting stress on the system. They essentially provide a flexible section in the conduit that can absorb the dimensional changes caused by temperature variations. The spacing and type of expansion joints needed depend on several factors, including the length of the conduit run, the temperature range expected, and the materials used for the conduits and their supports. Careful calculation and planning are essential to ensure that the expansion joints are properly sized and placed to accommodate the expected thermal movement. In addition to expansion joints, other strategies can be employed to manage thermal expansion, such as using flexible conduit sections or designing the support system to allow for some movement. The key is to recognize that thermal expansion is a significant factor in the design of any system involving different materials exposed to temperature variations, and to take appropriate measures to accommodate it. Failure to do so can lead to costly repairs, safety hazards, and even structural damage. Consulting with experienced engineers and contractors is crucial to ensure that thermal expansion is properly addressed in the design and installation of electrical systems on dams or other similar structures. When dealing with electrical systems, it's essential to consult the National Electrical Code, or NEC. The NEC provides comprehensive guidelines for the safe installation of electrical wiring and equipment. Several articles within the NEC are particularly relevant to the installation of conduits and conductors on a dam facade. Article 300 addresses general wiring methods and materials, including requirements for the use of approved raceways, such as conduits. It specifies that raceways must be securely fastened and supported, and that they must be protected from physical damage. Article 310 covers conductors for general wiring, including requirements for conductor ampacity, insulation, and sizing. It provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. Article 344 specifically addresses rigid metal conduit, or RMC. It outlines the permitted uses of RMC, as well as requirements for its installation and support. It specifies that RMC must be installed as a complete system, and that all fittings and couplings must be wrench tight. Article 352 covers rigid polyvinyl chloride conduit, or PVC. It outlines the permitted uses of PVC conduit, as well as requirements for its installation and support. It specifies that PVC conduit must be supported in accordance with Table 352.30, which provides minimum spacing requirements for supports. Article 356 addresses liquid-tight flexible metal conduit, or LFMC. It outlines the permitted uses of LFMC, as well as requirements for its installation and support. It specifies that LFMC must be supported in accordance with Table 356.30, which provides minimum spacing requirements for supports. Article 386 covers surface metal raceways and surface non-metallic raceways. These raceways are typically used for exposed wiring on walls or ceilings. They must be securely fastened to the surface and protected from physical damage. In addition to these specific articles, other sections of the NEC may also be relevant depending on the specific application. For example, Article 250 covers grounding and bonding, which is essential for ensuring electrical safety. Article 430 covers motors and motor circuits, which may be relevant if the dam has any electrical equipment associated with it. When installing conduits and conductors on a dam facade, it's essential to carefully review the NEC and ensure that all requirements are met. This will help ensure the safety and reliability of the electrical system. It's also important to consult with local electrical inspectors to ensure that the installation complies with all local codes and regulations. The selection of the appropriate type of conduit is crucial for ensuring the long-term reliability and safety of the electrical system. Several factors should be considered when making the selection, including the environmental conditions, the mechanical stresses, and the electrical requirements. Rigid metal conduit, or RMC, is a heavy-walled conduit that provides excellent protection against physical damage and corrosion. RMC is typically made of steel or aluminum and is suitable for both indoor and outdoor applications. RMC is more expensive than other types of conduit but offers superior protection and durability. Intermediate metal conduit, or INC, is a thinner-walled conduit that provides good protection against physical damage and corrosion. IMC is typically made of steel and is suitable for both indoor and outdoor applications. IMC is less expensive than RMC but still offers good protection and durability. Electrical metallic tubing, or EMT, is a thin-walled conduit that is typically used for indoor applications. EMT is made of steel or aluminum and is easy to bend and cut. EMT is the least expensive type of metallic conduit but offers less protection against physical damage and corrosion than RMC or IMC. Rigid polyvinyl chloride conduit, or PVC, is a non-metallic conduit that is resistant to corrosion and chemicals. PVC conduit is lightweight and easy to install. PVC conduit is suitable for both underground and above-ground applications, but is not as strong as metallic conduits. Liquid-type flexible metal conduit, or LFMC, is a flexible conduit that is used to protect wiring in wet or damp locations. LFMC is made of a flexible metal core with a liquid-tight outer jacket. LFMC is suitable for both indoor and outdoor applications and is often used to connect motors and other equipment that may vibrate or move. The size of the conduit should be selected based on the number and size of the conductors that will be installed inside. The NEC provides tables that specify the maximum number of conductors that can be installed in different sizes of conduit. It's important to select a conduit size that is large enough to accommodate the conductors without overcrowding. Overcrowding can lead to overheating and insulation damage. The support spacing for conduit should be in accordance with the NEC. The NEC provides tables that specify the maximum spacing between supports for different types and sizes of conduit. It's important to provide adequate support to prevent the conduit from sagging or becoming damaged. When installing conduits on a dam facade, it's important to use appropriate mounting hardware. The mounting hardware should be made of corrosion-resistant materials and should be securely fastened to the dam's structure. The mounting hardware should be designed to withstand the weight of the conduit and conductors, as well as any wind or ice loads. Grounding and bonding are essential for ensuring electrical safety. All metallic conduit and equipment enclosures should be properly grounded and bonded in accordance with the NEC. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. Bonding ensures that all metallic parts are at the same electrical potential, which reduces the risk of electrical shock. The cost of materials will vary depending on the type and size of the conduit, the type of mounting hardware, and the quantity of materials required. It's important to obtain quotes from multiple suppliers to compare prices and ensure that you are getting the best possible deal. The labor costs will depend on the complexity of the installation, the accessibility of the work area, and the skill of the installers. It's important to hire qualified and experienced electricians to ensure that the installation is done safely and correctly. Permitting and inspection fees may be required by local authorities. It's important to check with the local building department to determine what permits are required and what the fees will be. Contingency costs should be factored in to cover unexpected problems or delays. It's always a good idea to have a contingency fund to cover unforeseen expenses. The alternative vertical support options for conductors on a dam facade offer a range of solutions with varying costs and benefits. By carefully considering the factors outlined above, it's possible to select the most appropriate and cost-effective solution for the specific application. Consulting with experienced electrical contractors, structural engineers, and dam safety experts is highly recommended to ensure a safe and reliable installation.